The van der Waals equation for 1 mole may be expressed as Vm cube minus V plus RT divided by P Vm square plus AVm divided by P minus AB divided by P is equal to 0. That is, we've been given with a cubic equation in the molar volume, where Vm is the molar volume of the gas. We have to find which of these statements is incorrect. Okay. Now, by the definition of critical temperature, we know that critical temperature is the temperature below which a gas can be liquefied, right? So, if we talk about the first option, for a temperature less than Tc, V has 3 real roots, right? V is a cubic equation in V. So, since the gas can be liquefied, that is, it would occupy some volume below Tc. So, therefore, the equation would have real roots. So, this statement is correct. For a temperature less than Tc, V has 3 imaginary roots. Now, this statement is incorrect. Why? Because we know that below the critical temperature, the gas would liquefy. So, therefore, there would be at least one volume V existing. And since it is below the critical temperature, all the 3 roots would be real, right? There cannot be an imaginary root. Hence, the statement is incorrect. For a temperature equal to Tc, all 3 roots of V are real and identical. This is very much correct. Why? Because the 3 roots of V would correspond to the same phase, because at critical temperature there is hardly any difference between the densities and volumes occupied by the liquid and the vapor state, right? Therefore, for all the 3 states, that is all the 3 phases, or we can say all the 3 roots of the equation, all 3 of them would converge to one point, which will be the volume at that particular temperature. On increasing the temperature, however, keeping it below critical temperature, the 3 roots become closer to one another. Now, from statement 1 and statement 3, we have known that there are 3 roots, right? And as we approach the critical temperature, these 3 roots converge to a single point, correct? So we can say that if these were the 3 roots on the number line, as the temperature is brought to the critical temperature, these 3 roots would come very close and converge to one point towards the critical temperature, okay, which would correspond to the critical volume. So therefore, option D is also correct. So the only incorrect option is option B.